How safe is biotechnology in agriculture? Climate change, limited resources such as land and water, food wastage, malnutrition, pests and plant diseases are some of the major challenges we face today. A number of these challenges could be addressed through modern biotechnology, but the question remains, are they safe? Many are not aware that most food that we eat come from highly domesticated species. The wild varieties will not be able to give us enough yield. They are not resistant to current pests and diseases and even may differ in taste. This is a wild carrot, which is very much different from what we eat today. Here is a wild cauliflower and its related vegetables. This is a wild banana, tomato, kiwi and brinjal. All these food crops have been domesticated and their genetic makeup is quite different from what we eat today. Over the years, global food challenges were being addressed through conventional breeding technologies like crossbreeding and selective breeding. But these technologies have their limitations. They are often time-consuming and difficult to achieve a perfect outcome. Not all traits could be obtained through conventional breeding, since these methods work within related species. For example, there is no gene to increase iron absorption in any rice variety. So this gene has to be acquired from organisms not related to rice. This is where modern biotechnology involving genetic modification becomes handy. Here is how it is done. Genes, which are the hereditary units of any organism, determine the traits of that organism. Genes give us our physical looks and also produces all our enzymes and other proteins like hormones. To create a new desired trait in an organism, the gene responsible for this trait can be inserted into the organism from a donor organism. For example, there is a bacterium that produces a protein that kills insect pests. So the gene responsible to produce this protein can be inserted into crops like cotton, soybean and brinjal. These crops now will produce the same protein and be resistant to pests. They are also called insect-resistant crops. There are insect-resistant cotton, corn, brinjal and soybean. The gene is from the Bacillus thuringiensis, a common soil bacterium. The method is called a genetic modification. It allows farmers to reduce the use of insecticides. Some genetically modified crops are herbicide tolerant, where the herbicides only kill the weeds and not the crops. The gene comes from a soil bacterium. This helps farmers to manage weeds better. The golden rice is enriched with provitamin A that helps prevent blindness. For this, the gene comes from corn and other bacterium. While all sounds good, there are potential risks as well that must be addressed and managed scientifically. This is where biosafety becomes very important. Insects might become resistant to protein. Weeds and crops can also become too weedy and difficult to control. Cross-pollination with wild or other non-GM varieties, or deleterious changes in plant height and growing patterns. There may also be food safety issues to both humans and animals. It is imperative that we consider human, animal and environment safety before GM crops are approved and adopted for commercial use. Here is where biosafety kicks in. Risks are assessed from the start of developing any new GM crops. The new genes are tested for allergens and toxicity, and their stability is determined so there is no unintended interaction with host genes. Food safety is also assessed through different methods including feeding trials with animals. All GM crops must contain the same level of nutrition or anti-nutrition as their conventional counterparts. This is called substantial equivalence. Environmental safety is assessed by conducting contained, confined and field trials. This starts from the laboratories and moves to greenhouse, and finally to open field trials. Will there be any unintended impact to beneficial insects, change to the soil and its organisms, impact to wildlife or cross-pollination with wild varieties? GM crops are only approved if they are confirmed to be safe to humans and animals, and if the environmental risks can be managed. This is mandatory, especially for countries which are parties to the Cartagena Protocol on Biosafety. Sri Lanka is a signatory of the Cartagena Protocol on Biosafety signed in 2000 and ratified in 2004. The protocol aims to ensure safe handling, transport and use of GMOs resulting from modern biotechnology. To fulfill the obligations under the Cartagena Protocol on Biosafety, Sri Lanka prepared the National Biosafety Framework and the National Policy on Biosafety in 2005. The National Biosafety Framework outlines the biosafety regulatory process, which includes the mandatory risk assessment and public participation in decision-making. The Ministry of Environment is Sri Lanka's focal point to the Cartagena Protocol on Biosafety. Several other competent authorities support the implementation of the biosafety framework in Sri Lanka through proper risk assessment. The National Biosafety Project is implemented by the Ministry of Environment with technical support from the Food and Agriculture Organization of the United Nations and funding from the Global Environment Facility. Its objective is to strengthen Sri Lanka's regulatory, institutional and technical capacity for the effective implementation of the National Biosafety Framework in conformity with the Cartagena Protocol on Biosafety. Presently, Sri Lanka has not approved any GMOs to be used in the country. We do not have any GMOs being imported or grown in the country. But we need to be prepared, for our future demand and safety is of utmost priority.